Traffic management using AI. Beginner level. Introduction. Traffic management using AI means using artificial intelligence to control, monitor, and improve traffic flow on roads. Every day, cities face traffic problems such as traffic congestion, long waiting times at signals, road accidents, pollution from vehicles, inefficient route planning. AI helps solve these problems by analyzing real-time data and making smart decisions. Examples of AI in traffic management include smart traffic lights, traffic prediction systems, accident detection systems, smart surveillance cameras, real-time route suggestions. This topic helps beginners understand how AI improves urban transportation systems. It also teaches concepts like data collection, pattern recognition, real-time decision-making, automation, predictive analytics. What is traffic management using AI? Traffic management using AI is the use of intelligent systems to monitor and control traffic efficiently. In simple words, traffic management using AI equals using smart systems to reduce traffic and improve road safety. A beginner-level AI traffic system may include traffic monitoring, signal control, traffic prediction, accident detection, route optimization. Why AI is important in traffic management. Traditional traffic systems use fixed timers, which are not efficient. AI improves traffic systems by checkmark adjusting signals based on real-time traffic, checkmark reducing waiting time, checkmark preventing congestion, checkmark improving emergency response, checkmark reducing accidents, checkmark saving fuel and time. AI helps cities move towards smart city infrastructure. Basic features of AI traffic management systems. Feature purpose. Traffic monitoring collect real-time vehicle data. Signal optimization adjust traffic light timing. Congestion detection identify traffic jams. Accident detection detect incidents quickly. Route suggestion recommend alternative paths. Example traffic data. AI systems rely on real-time data like traffic_data equals cars 120, signal red, waiting_time 45, accident false, closing curly bracket. This data helps the AI system understand road conditions. Simple AI traffic detection example. Cars equals 80. If cars greater than 70. Print. Heavy traffic detected. Else. Print. Traffic is normal. This basic logic simulates how AI detects congestion. How AI traffic management works. Step 1. Collect data. AI collects data from cameras, CCTV, road sensors, GPS devices, mobile apps, traffic lights. Example. Vehicles equals 150. Weather equals rain. Step 2. Analyze traffic patterns. AI analyzes patterns such as number of vehicles, time of day, weather conditions. Example. If vehicles greater than 100 and weather equals rain. Print. High congestion expected. Step 3. Make smart decisions. AI adjusts traffic systems automatically. Example. If vehicles greater than 80. Print. Increase green signal time. Step 4. Provide real-time updates. AI systems provide live updates to drivers, traffic control centers, navigation apps. Example. Traffic_status equals heavy. Print. Alert drivers. Traffic is traffic_status. AI and smart traffic signals. Smart signals change based on traffic conditions. Example. Cars_waiting equals 60. If cars_waiting greater than 50. Print. Extend green light duration. Else. Print. Normal signal timing. This reduces waiting time at intersections. AI and traffic prediction. AI predicts future traffic conditions using historical data. Example: time equals 5 p.m. If time equals 5 p.m. Print: expect heavy traffic. Rush hour. Quote: this helps drivers plan better routes. In accident detection. AI systems detect accidents using cameras and sensors. Example: sudden_stop equals true. If sudden_stop, print: possible accident detected. This enables faster emergency response. In route optimization. AI suggests better routes to avoid traffic. Example: routes equals route A 30, route B 20, route C 40, closing curly bracket. Best_route equals min. Routes. Key equals routes.get. Print: best route. Quote: best_route. Full menu-based traffic management system. Python. Def check_traffic. Cars equals int. Input: enter number of cars. Quote: if cars greater than 70. Print: heavy traffic detected. Else. Print: traffic is normal. Def signal_control. Cars equals int. Input: cars waiting at signal. Quote: if cars greater than 50. Print: extend green signal. Else. Print: normal signal timing. Def accident_detection. Status equals input: accident detected? Yes, no. Quote: if status equals yes. Print: alert emergency services. Else. Print: no accident detected. Def route_suggestion. A equals int. Input: route A time. Quote: B equals int. Input: route B time. Quote: C equals int. Input: route C time. Quote: routes equals A, B, C, best equals min. Routes. Key equals routes.get. Print: best route is, quote, best. While true. Print: N1. Check traffic. Print: 2. Signal control. Print: 3. Accident detection. Print: 4. Route suggestion. Print: 5. Exit. Choice equals input. Enter choice. Quote: if choice equals 1. Check_traffic. If choice equals 2. Signal_control. If choice equals 3. Accident_detection. If choice equals 4. Route_suggestion. If choice equals 5. Break. Else. Print: invalid option. This simulates a basic AI-driven traffic system. Concepts learned from this topic. Learning AI in traffic management helps beginners understand. Checkmark real-time data processing. Checkmark decision-making systems. Checkmark pattern recognition. Checkmark optimization techniques. Checkmark automation in real-world systems. Real-life analogy. AI traffic management is like a smart traffic police officer who watches traffic continuously, understands traffic conditions, adjusts signals dynamically, warns about accidents, guides drivers. But AI can do this faster and continuously without fatigue. Ways to improve this project. You can make this project more advanced by adding real-time traffic API integration, computer vision, vehicle detection, machine learning models for prediction, smart parking system, emergency vehicle priority system, IoT-based sensors, dashboard for traffic monitoring, map integration, Google Maps API. Common mistakes beginners make. Cross-mark using fixed signal timing logic. Cross-mark ignoring real-time data. Cross-mark not handling edge cases. Cross-mark oversimplifying traffic conditions. Cross-mark assuming AI equals only complex models. Where AI traffic management is used. AI traffic systems are used in smart cities, highway management, urban traffic control centers, navigation apps, public transport systems, emergency response systems. Advanced systems also include adaptive traffic lights, vehicle tracking, predictive congestion systems, smart surveillance. Simple definition: traffic management using AI. The use of artificial intelligence to monitor, control, and optimize traffic flow for safer and more efficient transportation. Final summary: traffic management using AI helps cities reduce congestion, improve safety, and optimize transportation systems. It teaches beginners checkmark smart decision making, checkmark real-time system design, checkmark traffic optimization, checkmark practical AI applications. This is one of the most impactful real-world applications of AI in modern cities.